Let us continue with our discussion. We have been discussing the problems from the chapter Work Energy Power. These problems have been taken from the Conscience Physics book, ICC class 10. Okay, so let us come to the solution of the first problem. So what is the first problem about? Let us see. So solution number 1. Okay, the first problem given here says that how much energy is gained by a box of mass 20 kg when a man, first part says carrying the box waits for 5 minutes for a bus. Now, you know, I think the concept of work and energy is clear. See, when can we say that some work has been done? When there is a force applied on an object, so we can say that work is done when force is applied on an object. So first thing is that the force must be applied, and second thing is that there must be displacement. Okay, first thing is that there must be force, and second thing is that there must be displacement. Okay, so work done depends on these two factors, force and displacement. So in the first part of the problem, it says that a man is carrying the box, but he is not moving. He waits for the bus for 5 minutes. So although he is applying a force in order to lift up the box, but after he has lifted the box to a certain height, he is holding at that position for 5 minutes still, okay, without any movement. So I think definitely the work done in the first case will be how much? You can guess, it's 0, isn't it? So we will be writing here, first of all, if I consider the given points. Okay, so what are the given points? Let us write given is the mass of the box. What is the mass of the box? It's 20 kg, isn't it? 20 kg. Fine. So definitely the weight of the box will be, if I consider the value of g as 10 meter per second as it has been given, it will be 20 into 10, 20 into 10, that will be equal to 200 Newton. Okay, 29 is 200 Newton. Fine. Now first part, the work done will be definitely 0, as because the person is just holding the box at a certain height without any movement. So ultimately displacement is 0, so work done is 0. Why this work done is 0? Since displacement s is equal to 0, that is why the work done is 0. Okay, now coming to the second part of the problem. So what does the second part says? It says runs carrying the box with a speed of 3 meter per second to catch the bus. Okay, so there is a theorem called work energy theorem. I think you must be knowing this. If you have known, so I can say that the change in the kinetic energy of a body can be due to the work done upon the body. So whenever I can calculate the change in the kinetic energy, definitely that change is due to the certain work done on the body. So I can say that the box is initially at rest. So I can say initial speed of the box, initial speed of box is equals to, let us consider it to be u, it is 0 meter per second. Okay, final speed of the box, final speed of the box denoted by letter v is how much speed is the man moving with? 3 meter per second. So it's 3 meter per second. Okay, so I can say that the initial and final kinetic energy, so change in kinetic energy, so change in kinetic energy I will write it as delta ke. Change in kinetic energy is equals to final kinetic energy half m v square minus initial kinetic energy half m u square. So as the initial speed is 0, the initial kinetic energy is 0, final kinetic energy it comes out to be half into mass is 20 kg into speed is 3 square. So calculating this value comes out to be, it's 10, so 90 joule. Okay, So the change in kinetic energy is 90 joule. Now, according to work energy theorem, the work done on the body is equal to the change in kinetic energy. Hence, you can write, therefore, work done is equal to change in kinetic energy. This is according to work energy theorem, and that will be equal to 90 joule. Okay, so this is according to work energy theorem. Okay, work energy theorem. Fine. So this is the solution of the second part. Now, coming to the solution of the third part, what is the question in the third part? Just let us see. Third part says the box has been raised by an height of 0.5 meter in order to place it inside the bus. Then what is the work done? So definitely, when the box is raised to a height of 0.5 meter, the work done will be equal to the increase in potential energy. You also know that when a object is moved very slowly, the work done on the object is stored in it as potential energy. So here we can say that work done will be equal to increase in potential energy. Okay, it will be increase in potential energy. Fine. Work done equal to increase in potential energy. Okay. What is the increase in potential energy? So it is given by the formula mgh, isn't it? M, G and H. The mass is 20 kg. G is equal to 10 given, and height raised is 0.5 meter. So what is the total work done? 5 into 20, that is equal to 100 joule. So this is our work done. Okay, so the solution is clear. So this is the work done when the box has been raised up to a height of 0.5 meter. Okay, so the solution of the first problem is complete. Now let us move on to the second problem. What does the second problem say? A bullet of mass 50 gram is moving with a velocity of 500 meter per second, penetrates 10 centimeter into a steel target and comes to rest. Very good. So it has been given that a bullet, when hits a solid target, penetrates 10 centimeter and then stops. So we have to calculate the kinetic energy possessed by the bullet. So definitely, first of all, let us write what are the given information: mass and initial velocity. Mass and initial velocity. So given information. So this is our solution number 2. Solution number 2. Okay. So let's, what are the given informations? Given is that mass is 500 gram. Mass is equals to 500 gram. So if I convert it SI unit kg, it will be 500 by 1000, 0.5 0.5 kg is the mass. Okay, what is the initial velocity? So the initial velocity is given as initial velocity u is equal to, how much is the initial velocity? 500 meter per second. So it's 500 meter second inverse. Okay, fine. And as it penetrates 10 centimeter into the steel target, comes to rest. So definitely final velocity will be 0. Okay, final velocity denoted by the letter v will become 0 meter per second. Okay, fine. And what is the distance of penetration? So distance has been given as distance denoted by the letter s, denoted by the letter s. So it is 10 centimeter. If I convert into it, 10 by 100 meter, so 0.1 meter. Okay, fine. Okay, now what else it has been given? So it has been asked, what is the kinetic energy possessed by the bullet? So when the bullet, so first part of the solution, when the bullet is moving at a speed of 500 meter per second, having a mass of 0.5 kg, it will be having a kinetic energy of half mu square. Okay, so kinetic energy possessed by bullet is equal to half mu square. Okay, so that is equals to half into mass is 0.5 kg, so I can write it as 0.5 kg also means half, 0.5 kg into u square means 500 square. Okay, so this turns out to be 1 by 2 into 0.5 can be also written as 1 by 2 into 500 into 500 means 25, then 4 zeros. Okay, so 25 by 4, isn't it? Okay, so I can see we can do this calculation in a tricky way. So this turns out to be 1 by 4 into, if I say that, if I just take out this 2500 and write it as 25 4 zeros, so can I 2500 into 100, can I write it? Yes, definitely yes. So this 4 and 100 cuts out this 25, so 25 squared, do you know what is 25 squared? It's 625. So 625, and then there will be 2 zeros, so this 625 then 20, this is the amount of energy that is in joule that the kinetic energy was for the bullet. Okay, so this is the first part of the solution. Okay, then what is the next problem has been asked. Next subpart, what is the subpart saying? It has been said the average retarding force offered by the rocket. Okay, fine. So here you can apply one technique, that you know that the average retarding force. Okay, so I know so you know that the is work done is equal to force into displacement, isn't it? So here I can say the work done is equal to the change in kinetic energy. So what is the change in kinetic energy? If I consider the change in kinetic energy, final minus initial, so ke final minus ke initial, if I just consider this, then it will be 0 minus 625, then there are two zeros, so this turns out to be minus 62500 joule. So this is the change in kinetic energy. Now this change in kinetic energy is equal to the work done, so I can say that work done is again given by the formula force into displacement if the displacement is in the direction of the force. Okay, force into displacement. Okay, here the retarding force is in a direction opposite, so we will get the opposite negative sign in the calculation. Just see. So I can say that the work done is equal to minus 62500. So if I consider the retarding force to be F, then minus 62500 will be equals to force into displacement is given as 0.1 meter. So it's 0.1 meter. Okay, or I can say that force F is equals to minus 62500 by 0.1. This turns out to be minus 62500 Newton. Okay, so this is the force acting, and the negative sign comes as because this force is retarding force, the direction of the force and displacement are opposite, hence the negative signs come. So this is the value of the force applied. Okay, so retarding force applied is 62500. So I can write, therefore retarding force equals to, if I write retarding force, then no need to use the negative sign. Retarding force is equals to 62500, no sorry, 000 Newton. Okay, so this is the solution of the second problem. Fine, now let us quickly move on to the solution of the third problem. So this is solution number 3. Okay, so what is the question given here? Question number 3. Spring is kept compressed by a small trolley of mass 5.5 kg lying on a smooth horizontal surface. When trolley is released, it is found to move with a speed of 2 meter per second. Then what potential energy did the spring possess? Okay, so you can see that we know that about the conservation of mechanical energy, the sum total of potential and kinetic energy for a system remains conserved, isn't it? Here, when the spring is compressed, it develops potential energy, spring potential energy. Now, when the trolley is released, the spring is released, the spring unwinds itself or changes it from the compressed state to the relaxed state. In the process, it will release all the potential energy into kinetic energy. So if I can calculate the value of kinetic energy, then definitely that kinetic energy value will be equal to the value of the potential energy in the compressed spring. So what are the given informations here? Given is mass of the trolley. So mass of the trolley is 0.5 kg. 0.5 kg is the mass of the trolley. Okay, and what is the value of the speed? 2 meter per second. Okay, 2 meter per second. 2 meter per second. So speed is equals to 2 meter per second. Okay, fine. Hence what will be the kinetic energy? Therefore kinetic energy of the trolley when it is moving is half into m into v square. So this turns out to be half into m means 0.5 into v square means 2 square. So you can write half into 0.5 means also half into 4. So this comes out to be 1 joule, isn't it? 1 joule. Now this kinetic energy, where does it come from? This kinetic energy comes from the potential energy of the compressed spring, isn't it? Therefore I can say that the potential energy of spring is equal to the kinetic energy of the spring equals to, it is given as 1 joule. Okay, so this is the answer. So I think the solution number 3 is also clear. The question number 3 was relatively easier than question number 1 or 2. Okay, so today will be ending our class here. See you in the next class. Thank you.